SANDHAN, All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.
Good afternoon friends. Today we are going to talk on fiber optics and optical fiber communication. Fiber optic is the greatest innovation in the field of communication. Up to these days we were using copper cable, coaxial cable, twisted pair wires. Nowadays what we are doing, we are using the fiber optic cables. So fiber optic is the, you can say, media which is used to carry the information from one end to another end. Basically it consists of core and cladding. You can say optical fiber is basically a solid glass rod. The diameter of rod is so small that it looks like a fiber. Optical fiber is a dielectric waveguide. Here the waveguide word is used for the fiber cable. The light travels like an EMW inside the waveguide. EMW, electromagnetic wave. Electromagnetic wave, a wave that propagates by the interchange of energy between the electric and magnetic fields. The dielectric waveguide is different from a metallic waveguide which is used at a microwave and millimeter wave frequencies. In a metallic waveguide, there is a complete shielding of electromagnetic radiation, but in an optical fiber, the electromagnetic radiation is not just like confined inside the fiber but also extends outside the fiber. The light gets guided inside the structure through the basic phenomenon of the total internal reflection. The optical fiber consists of two concentric cylinders. You can say one is the core, another is the cladding. Here, three figures indicates the different phenomenon. One is the figure number A, where the angle of incidence is less than the critical angle. In figure B, the angle of incidence equal to the critical angle, and in figure 3, angle of incidence is greater than the critical angle. So here picture shows the total internal reflection takes place inside the fiber cable. Figure shows the center part is a core, outer part cladding, and the outermost part is the jacket. In fiber optic communication, basically there are signal source which generates the information, then it is allowed to reach up to the optical transmitter through copper cable. Then with the help of fiber optic cable, that information is reached at the optical receiver, where suitable transducer is used to convert the optical signal into the electrical, and again through the copper cable the signal is received in the particular form. For the light to propagate inside the fiber through total internal reflections at a core cladding interface, the refractive index of the core must be greater than the refractive index of the cladding. You can say refractive index of core is N1 and refractive index of cladding is N2. So you can say N1 should be greater than N2. Refractive index basically is the ratio of speed of light in a vacuum to the speed of light in a material. One word is there, refractive index profile. The way the refractive index varies as the distance from the fiber center varies. For propagation of light inside the core, there are two possibilities. One, a light ray is launched in a plane containing the axis of the fiber. Light ray, after total internal reflection, travels in the same plane. That is, the ray is confined to the plane in which it was launched and never leave the plane. In this situation, the rays will always cross the axis of the fiber. These are called meridional rays. The other possibility is that ray is not launched in a plane containing the axis of the fiber. For example, if the ray is launched at the some angle such that it does not intersect the axis of the fiber, then after total internal reflection, it will go to some other plane. In this situation, the ray will never intersect the axis of the fiber. The ray essentially will spiral around the axis of the fiber. This is known as a skew rays. So it can be concluded that if the light is to propagate inside the fiber optic cable, then there are the two types of phenomenon can occur. There are two types of rays, you can say. One is a meridional rays, the ray which always passes through the axis of fiber, giving high optical intensity at the center of the core. And in a skew rays, it will never cross the you can say axis of the fiber, giving low optical intensity at the center and high intensity towards the rim of the fiber. Now in fiber optic cable, one word, that is you can say numerical aperture, is very important. This is the parameter which tells that if we take an optical fiber and put it in front of optical source, there are two types of sources one can use. One is the LED, another is the laser. Then how much light is collected by the fiber from the source. So smaller the value of numerical aperture, smaller is the power accepted by the fiber. In other words, if light is available from various directions from the source, only a portion of light is accepted by an optical fiber and the remaining part of the light is rejected by it. Larger the numerical aperture means more modes, and more modes also means higher the dispersion. We will see the word dispersion later. Larger diameter of the fiber cable yields more modes and higher dispersion. All rays with angle less than critical angle will propagate in the fiber. Other rays will propagate at distinct angles below the critical angle. These rays are referred to as the modes of propagation. Total number of modes propagation in a fiber increases as the critical angle increases. Higher order modes and lower order modes are the two modes in optical fiber communication. Higher order modes, those with propagation angles close to critical angle. The high order modes tend to send light energy into the cladding. This energy is ultimately lost, particularly at fiber bands. Low order modes, those with propagation angles much lower than the critical angle. Higher dispersion means lower data rate, which leads to a less efficient transmission. If numerical aperture is reduced to reduce the dispersion, this is not advisable for the two reasons. If one wishes to reduce the numerical aperture, then why it is not advisable? We can see the two reasons. Injecting light into fiber with lower numerical aperture becomes difficult. Lower numerical aperture means lower acceptance angle, which requires entering light to have a very shallow angle. Leakage of energy is more likely and hence losses increases. Dispersion. The word dispersion means pulse broadening effect by the, you can say, fibers. The amount of light accepted by an optical fiber is only one of the parameters in optical communication. A more important parameter is the data rate which the fiber can handle, since the primary purpose here is to send information from one point to the another. Acceptance angle. The range of angles within which an injected light beam will enter the fiber. Acceptance cone. The acceptance angle in a 3 dimension is known as the acceptance cone. Here you can say acceptance cone is shown and acceptance angle is shown in the figure. The time difference essentially is the measure of pulse broadening on the optical fiber. You can say dispersion. This phenomenon is called the dispersion of an optical fiber. The dispersion, you can say pulse broadening, has to be small since the data rate is inversely proportional to the pulse broadening. If one wishes to increase the data rate, then dispersion should be small, and if we want to increase data rate, dispersion ઓછું કરીએ તો શું થાય કે આપણી જે સિગ્નલની સ્ટ્રેન્થ છે એ મેક્સિમમ રહે અને સિગ્નલ લોસ છે એ ઓછો રહે. Here, if we try to see for a high speed communication, what is the meaning of high speed communication? High speed does not refer to the time taken by the data to reach the destination, but it refers to the number of bits per second. So for high speed communications, the pulse broadening and hence the dispersion should be minimum. Data rate. The highest rate of digital binary information that the system can handle. You can say it is related to the bandwidth of the optical fiber. Fiber loss. The loss of energy of light as it travels along the fiber expressed in decibels per kilometer. Repeater station. Now what happens as we transmit the information from one end to the another end, if the distance is very much far, then as the signal travels from one end to another end, the signal loss may occur. So what is the advisable task one should do? One should use the repeater at a certain level, certain distances. Suppose repeater is nothing but there are 3 components are accommodated in a repeater. One is the receiver, another is the amplifier, and third one is the, you can say, transmitter. So repeater station is a device or a system used to receive, you can say receive here is an amplifier, the signal along the transmission cable. there is a profile mismatch. If the fiber optic cables what we are using are of not suitable length, then what we need to do, we are, you can say, joining the two fibers. So profile mismatch may occur. The shape of the two fibers ends is not in the same, I can say, group. There are three fundamental causes of light loss in a fiber. One is the material loss, another is a light scattering loss, and third one is the waveguide and band losses. Material loss, absorption by the material. This includes the absorption due to the light intersecting with the molecular structure of the material, as well as loss because of material impurities. Light scattering, the light scattered by the molecules of the material by structural imperfection and impurities. Waveguide and band losses, losses caused by imperfection and deformations of the fiber structure. The term waveguide or optical waveguide is often used in the place of optical fiber. Microbands. So you can say, if we try to manufacture any fiber optic cable, then the core, you can say, structure of the core should be uniform. If there is any minute disturbance in a core, then what happens? Transmitted signal which is in a light form will be reflected back towards the source, and hence one can say there is a loss of the information. So such type of microbands are very much important, or to find out such type of microbands are very important, because it is creating the loss in a fiber cable. So is a very minute disturbances in a core size cause radiation of light. In a most of instances, the loss results from the scattering of light. So one can see from the figure that there is a very minute, you can say, disturbance inside the core, and hence this disturbance, this you can say bend, the light, incident light gets reflected back towards the source, and hence there is a loss of the signal at the output side. Back scatter, the light scattered back in the direction of the light source, typically caused by the obstruction or the microband. Then there is a loss due to the OH ion, an impurity in the fiber typically caused by the water condensate present during the manufacturing process. So during the manufacturing process, one objective is to minimize this OH ion present in a fiber optic cable. Different types of fibers. There are basically three types of fibers we will discuss. One is the step index fiber. For this fiber, the refractive index, you can say Ri, of the core is constant. Core Ri is constant. Since Ri profile looks like a pulse or a step, this kind of fiber is called the step index fiber. Generally, it is not used in practice because data transfer rate in this fiber is the lowest. So this one is the index fiber profile for the Ri. You can say index fiber. N1 and N2 is shown, where N1 is the refractive index of the core and is constant throughout the length of the fiber. Then there is a graded index fiber, you can say GI fiber. In a step index fiber, since the refractive index is constant inside the core, the velocity of all the rays is constant, and hence there is a travel time difference between different rays. In this fiber, you can say GI fiber, we grade the refractive index profile of the core, and consequently it is called the graded index fiber. So this is the, you can say, arrangement or a picture of the graded index fiber, where the refractive index of the core changing from center to the, you can say, boundary, where N1 and N2 are the refractive indexes of the core and cladding respectively. The optical fiber in which only one ray travels along the axis of fiber is called the single mode optical fiber. Single mode optical fiber is the best amongst the three types of fibers, you can say step index, graded index and a single mode fiber. But what is the problem with this single mode optical fiber? There is a very less amount of data can be carried from one end to the another end, and hence it becomes more costlier because data width is required in a communication, fiber optic communication. In a long distance communication, we use single mode optical fiber, whereas in a LAN, you can say local area networks, we generally use graded index optical fiber. Note, for single mode optical fiber, however, we have to use a source like laser, because the diameter of the fiber is very small, and without a highly collimated beam, sufficient light cannot be launched inside the fiber. Limitations of the ray model. Up to this, what we have studied, all the assumptions, all the theory based on the ray model. The ray model gives an impression that during the total internal reflection, the energy is confined to the core only. However, is not like so. It's really the optical energy spreads in a cladding also. The ray model does not speak of the discrete field patterns for propagation inside a fiber. The ray model breaks down when the core size becomes comparable to the wavelength of the light. The ray model therefore is not quite justified for a single mode optical fiber. The limitations of the ray model are overcome in a wave model. Now the advantages of fiber optics. You can say fiber optics gives you much higher bandwidth in gigabits per second. Thousands of channels can be multiplexed together over one strand of fiber. Multiplexing means accommodating a more signals. There are three types of multiplexing. One is a time division multiplexing, frequency division multiplexing, and wavelength division multiplexing. We will see all three multiplexing methods in detail in a later part. Immunity to the noise, immune to electromagnetic interference. Safety is the important parameter in industry. Doesn't transmit electrical signals. Here we are transmitting optical signal. Hence it is where gas pipelines or hazardous environment is there. This one is the suitable method of the communication. High security is again important parameter in the communication. Impossible to tap into. One cannot, you can say, tap the information from the optical fiber. So security is important here. Losses and the less losses. Repeaters can be